Hello, and welcome to this short video showing you how to integrate the GJD range of IP security devices into a Crestron project. GJD make a very nice range of PoE powered IP security products. These consist of the D-TECT range of motion sensors, the Clarius range of infrared and visible light illuminators, and the IPA, which is an I/O controller that can integrate multiple inputs and relay outputs into your project. Now let's open simple windows and take a look at how we integrate the GJD devices into your project. The zip file that you have received contains a sample project already, set up with one of each type of the supported devices, the D-TECT, the Clarius and the IPA. So here we have opened up the project and you can see the drivers instantiated. We are just going to go through these one at a time. First one we want to look at is the comms driver. This creates a TCP server that the GJD devices send notifications to. This driver is very straightforward. It just has a port number that you can configure, and this is the port of the server that is created within the Crestron processor. There is a single string output from the comms module, and whenever the module receives a notification from any one of the devices, that received data is sent out on the string to all of the attached modules. So here you can see that signal is routed to all instances of the devices that we have got in this project. Each device module makes a decision as to whether that notification is intended for it, and if it is, then it processes it accordingly. If not, it just simply ignores it. So now we're going to take a look at each of the device types in turn. Let's start with the D-TECT. If you recall, this is a PoE powered motion sensor. First off, we need to configure the module as to which device to talk to, and that is done via specifying the IP address here and the username and password for access. The IP address is used for when we are controlling the device, but also it's used to match up the notifications that come via this HTTP RX signal. If you recall, notifications from all devices are broadcast to all modules in the project, and this notification includes the IP address of the originating device. Consequently, each module knows which IP address it is controlling and can just filter out which notifications are for it and ignore all others. One really nice thing about the module is that it automatically configures the D-TECT device, so there is no configuration required on the D-TECT device itself. All the events are configured by the module. In order to achieve that, we need to give the module a few parameters, and you can see these available here. These specify the upper and lower temperatures for raising temperature alarms. It also specifies the lux level at which the low light alarm is generated, and then there is the setting that determines whether the PIR alarm is activated always or whether it is above or below the certain light limit, and the light limit is specified there. Looking at the signals then on this module, that we have the feedback that indicates when the PIR has actually been triggered, the feedback for the actual temperature value and whether we are above and below the limits, likewise for light level, the actual light level in lux, and digital for whether we're above those limits. Tamper, relay outputs, we have the state of the relay indicated here, and then we have signals here for triggering that relay to switch on and off, and we can also trigger the walk test switching that on and off with feedback as to what state we're currently in. If the tamper's been triggered, we have a signal here for resetting that. There is also a signal here to force reconfiguration of the alarms. You shouldn't normally need to use this, as the module will automatically configure the device when the process starts up. The Clarius is a PoE powered IR and visible light illuminator, and it is set up to a very similar manner to the D-TECT unit. If we look at the properties, we've got IP address, username and password as we'd expect, and then our parameters for upper and lower temperatures for raising the alarms and light level. Now, looking at the signals on the module, you can see a number of signals related to the controlling the LEDs. These consist of analog signals for setting power and timeout values, and then digitals, which you have to pulse to switch the LEDs on and off in the various modes. The important thing to note is that the analog values do not trigger an update on the device. They are for setting a value, and then the device is updated when you pulse the digital on or off. We also have feedbacks as to what state the LEDs are in. The Clarius has a single relay output which we can control on and off by pulsing these digital inputs, and we show the associated states. It also has a single digital input, and the state of that input is reflected by this digital output signal. Like the D-TECT, we have the tamper feedback and signal for resetting the tamper if it's been triggered. We have the feedback of the light level in lux, and a digital indicating whether the low light level alarm has been triggered or not, and likewise for temperature alarms we have a string value representing temperature and digitals for upper and lower temperature alarms. So now let's have a look at the IPA. If we look at the properties in that, we've got the IPA address, username and password as we'd expect. This device has 4 digital inputs, 1 analog input and 3 relay outputs. On the digital inputs, as well as detecting a high or low level, we can also detect our frequencies, and we can set alarms for high and low frequency alerts. We need to configure these in the parameters, and here you see the configuration for upper and lower frequencies for the 4 digital inputs. Also, we need to configure the upper and lower limits for the analog input, and likewise for the temperature measurement. If you then look at the signals at the top, here we see the signals relating to the 3 relays. We can switch them on and off individually, and we get feedback as to what state they are in. For the digital inputs, we have feedback as to whether they are detecting a high or low signal, and also if there is a frequency alarm being detected, and this is replicated for the 4 inputs. Likewise, for the analog input, there are alerts for upper and lower limits being exceeded, and also a string output indicating what the current value of the analog output is. The temperature, we have string output of the current temperature together with digitals that indicate whether the upper or lower levels have been exceeded. We haven't provided a touch panel design for these modules, as they are most effectively evaluated in Simple Debugger. Simply run the project in Simple Debugger, then you have full access to controlling the signals and monitoring the various events that are being received. Thank you very much for looking at this video. If you have any further questions, contact details are now showing on the screen.